The third and final way we can solve a quadratic is by using the quadratic formula. So any quadratic can be solved by the quadratic formula. Unlike in section 2 where only some quadratics can be factored, and when we were doing completing the square, some quadratic it's not nice to do completing the square. So for any quadratic, you can always use the quadratic formula to solve it. So if you're going to use the quadratic formula to solve a quadratic, it does need to be set equal to 0. So as long as your quadratic is ax squared plus bx plus c equals 0, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So you plug in the numbers for a, b, and c into the formula and simplify. You don't plug in the variable x at all. Okay. Another important piece to the quadratic formula is what we call the discriminant, and that's the number that's underneath the square root, which is the b squared minus 4ac. Now that discriminant can help us determine the types of solutions our quadratic has without solving first. So if our discriminant is equal to 0, then we have one rational solution. So that means that we get negative b over 2a because I'd be doing plus or minus 0, which doesn't change it. If b squared minus 4ac is less than 0, we have two complex solutions. So that's when we get negatives underneath the square root, and that's when I is going to be part of our final answer. So those are complex numbers. Okay. If it's greater than 0, there are actually two possible solutions. So b squared minus 4ac is greater than 0. There are two potential answers. We could have two rational or two irrational solutions. And whether it's rational or irrational is based on whether or not you have a perfect square. So if b squared minus 4ac is greater than 0 and a perfect square, that's two rational solutions. So by perfect square, we're talking about, for example, the numbers 1, 4, 9, 16, 25, keeps going. Because those are the numbers I can take the square root of and I'm going to get a whole number. The irrational numbers are when if you take the square root, you end up with a decimal, like the square root of 2. Not a nice number. 5, 6, 7, 8. I mean, the majority of numbers are irrational when it comes to taking the square root. Okay, we'll talk more about that in a little bit. So let's start by doing some examples where we solve quadratics using the quadratic formula. So we have x squared minus 4x minus 2 equals 0. So you need to double check it's equal to 0, and it is. And I always like to identify a, b, and c first before plugging into the formula. So a is 1, b is negative 4, and c is negative 2. So when I plug it into my formula, I have x equals negative b, so it's going to be negative 4, plus or minus the square root of negative 4 squared minus 4 times 1 times negative 2 all over 2 times 1. So the hardest part about the quadratic formula is making sure you plug in your numbers correctly, because the rest of the steps is just simplifying this equation. So negative 4 is going to become positive 4, plus or minus. The important thing, so the reason I put this negative 4 in parentheses is because I am squaring the number negative 4. If I don't put parentheses around it, I'm not going to get the right answer. So when I square negative 4, I get positive 16. And then we have negative 4 times 1 times negative 2, which is going to give positive 8 divided by 2. So adding my numbers, I get 4 plus or minus the square root of 24 all over 2. Now I want to see if I can simplify 24. Now 24 isn't a perfect square, but if you remember from Module 3, we did talk about how to simplify radicals. So I can break down 24 as 12 times 2. 12 becomes 4 times 3, and 4 becomes 2 times 2. So I have a pair of 2's that I can bring outside my square root. So I get 4 plus or minus 2 square root, and then the 3 and the 2 are going to multiply back together to get square root 6 all over 2. My last step is, once I've simplified the radical, to see if the numbers can then simplify. So the numbers that I'm looking to simplify are the numbers outside the radical, which in this case are 4, 2, and 2. And see if they can divide by anything. And they're all divisible by 2. So I'm going to get 2 plus or minus the square root of 6 as my final answer. So that means 2 plus square root 6 and 2 minus square root 6 are my solutions. Next example we have is 2x squared minus 4x minus 3 equals 0. Again, I'm going to identify A, B, and C. So A is 2, B is negative 4, C is negative 3. So I have x equals negative negative 4 plus or minus the square root of negative 4 squared minus 4 times 2 times negative 3 all over 2 times 2. Negative negative 4 is going to become a positive 4 plus or minus. And then negative 4 squared is positive 16. Negative 4 times 2 times negative 3 is going to give us positive 24 all over 4. And then 16 plus 24 is going to be 40 all over 4. So now I need to see if the square root of 40 will simplify. So I can break down 40 as 4 times 10, and 4 is 2 and 2, and 10 is 5 and 2. So I get 4 plus or minus 2 square root 10, because the 5 and 2 are going to multiply back together, all over 4. Then I check to see if 4, 2, and 4 can simplify, and those are all even numbers, so they're going to divide by 2. So I'm going to get 2 plus or minus the square root of 10 all over 2. Last example we have is x squared plus 1 equals x. So I'm not currently equal to 0. So my first step in this example is actually going to be to subtract x. So we get x squared minus x plus 1 equals 0. Then we have a equals 1, b equals negative 1, and c equals 1. So x equals negative negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 all over 2 times 1. We end up with 1 plus or minus the square root of 1 minus 4 all over 2. And then 1 minus 4 is negative 3. So we have 1 plus or minus the square root of negative 3 all over 2. Anytime you have a negative underneath the square root, that means that I is going to be part of your final answer, because that represents a negative 1 underneath the square root. So we're going to have x equals 1 plus or minus. So I know I'm going to have my I. The next thing I need to check is to see if the number underneath the square root will simplify. And 3 doesn't simplify, because 3 is just 1 times 3. So it's going to be 1 plus or minus I square root 3 all over 2. And there is no simplifying anything, so that's going to be the final answer. So the next example, x squared plus 25 equals 8x. So again, I have to get it equal to 0, so we're going to subtract 8x from both sides. So we get x squared minus 8x plus 25 equals 0. So A equals 1, B equals negative 8, C equals 25. So we're going to have x equals negative 8 plus or minus the square root of negative 8 squared minus 4 times 1 times 25 all over 2 times 1. So it's going to become 8 plus or minus the square root of 64 minus 100 all over 2, which becomes 8 plus or minus the square root of negative 36 all over 2. I do have a negative underneath the square root, so I know I'm going to have I in my answer. So I'm going to have x equals 8 plus or minus. I'm going to have I. Now I look at 36, and the square root of 36 is 6, so it's going to be 6i all over 2. And then 8, 6, and 2 are all divisible by 2, so I get x equals 4 plus or minus 3i. Last example. So this last example is a very rare type of example I'm going to see. So the left side is factored, and instead of being equal to 0, I'm equal to a number. So my first step is going to be to distribute into the parentheses. So x times x is x squared, x times 2 is 2x, negative 1 times x is negative x, and negative 1 times 2 is negative 2, and then equals 5. I'm going to combine like terms, so I get x squared plus x minus 2 equals 5. Now, in order to use the quadratic formula, I have to be equal to 0. So now I'm going to subtract 5. So I get x squared plus x minus 7 equals 0. So A is 1, B is 1, and C is negative 7. So I plug it in my quadratic formula. I'm going to have negative 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 7 all over 2 times 1. So we get negative 1 plus or minus the square root of 1 plus 28 all over 2, which is negative 1 plus or minus the square root of 29 all over 2. Now I check my radical. So the square root of 29 isn't going to simplify. 29 is a prime number. It only simplifies to 1 times 29, which means this is going to be my final answer. So in all of these examples, I could have looked at the discriminant first to determine what type of solution I had. So like on this last example, b squared minus 4ac, which was what was underneath my radical, ended up being 29. And based on that number, 29 is not a perfect square. I know that it has two irrational solutions based on that. So I would have known ahead of time that my final answer was going to involve square root. On the example we did before that, b squared minus 4ac equaled negative 36. And yes, while 36 is a perfect square, negative 36 was less than that. There's a negative in front, which makes it less than 0, which told me ahead of time that I was going to have two complex solutions. That would have told me at the beginning I'm going to have I in my final answer. Right. So it is important that you're able to identify from a discriminant the type of solutions you're going to have. If you have any questions about the discriminant or about the quadratic formula itself, please let me know.